Okay, YouTube, this is my next video in my module on graphing inequalities in two variables. And specifically, we've been looking at linear inequalities up until now. What we're going to be focusing on now going forward is nonlinear inequalities in two variables. And so specifically, there are some different shapes that we will be graphing often, and one of them happens to be a circle involved with an inequality. So you can see that this very first nonlinear inequality we have here, we have some x squared plus y squared is less than or equal to 9. And so the very first thing I want to do, at least when it comes to graphing this, is replace our inequality sign with an equal sign and say that this is what we would like to graph first. So with respect to graphing an inequality, we're still going to graph the equation associated with this first. And so let's go ahead and mention a few things here, starting with this. The equation of a circle centered at the origin is x squared plus y squared equals r squared. And so this is the equation of a circle centered at the origin. So centered at the origin, or at 0, 0. And so with respect to these kind of circles here, we'd say, well, x squared plus y squared equals, I guess this 9 is our r squared. We could say that really this is a circle of radius 3. Okay. So we would say, since I know the radius is 3 and we're centered at the origin, then what I want to do is go graph this circle here. Now I notice that because I have a less than or equal to, then I'm going to use a solid line. But the way this would look is basically from the center here, we're going to go 3 north, okay, 3 above, 3 right, 3 left, and 3 down. And so we're going to graph this circle here, and because it's an or equals to, we're going to use a solid line. But we're going to say that there's a circle that is a radius of 3 centered around the origin right here. So we're labeling this. When we label these, remember that we use the equation to represent all of the points actually on this graph here. But what we want to do now is choose a test point. So our test point just has to be in one region or the other. And when it comes to splitting the whole plane into half planes, you could see that it doesn't really feel like a half plane here. But we split the plane up into either inside the circle or outside the circle. So in terms of, are there any points that we could test that are not on the circle? Well, 0, 0 is most definitely not on the circle, even though it's the center. So we're going to test 0, 0, and we test this in the original inequality. So remember that if x squared plus y squared is less than or equal to 9, then what we're going to do is we're going to plug this point back in, and we're going to say, hey, do we get a true statement or not? So with these being both 0, it looks like we get 0 plus 0 is less than 9, and 0 less than or equal to 9 is definitely a true statement. So since it's true, then this point in here is true. But because it's true, then it means that all points in the middle of this circle here have to be solutions to this inequality. Another way to list this here would say that, we've got all these arrows kind of coming in together saying that we would shade within the circle here. All of the points on the inside of this would make this original inequality true. So what I'd like for you to try is just again here, I'll give you another circle, but I want you to graph the section of the plane associated with this inequality here by first graphing the circle and then choosing a point to test and shading appropriately afterwards. Cheers.